take a deep breath and get ready to be scientists. That would be great.
Yeah.
So here's our question for today. We have to find out every material that is in this room.
Everything is a material.
But we want to name what they are. This is like a cookie. Look under here.
Oh, yeah.
Ooh, that's a good one.
See how this plastic moves like this? And look at this plastic. Feel that.
Oh, and then there's the plastic bins over there. Wax, soft plastic, hard plastic, magnet, tin foil, glue. Feel it. It's weird.
Yeah, that's right. It could be a material that's a mixture of plaster and wood. That's plastic.
Like this part. What is that ready?
Because the
Yeah,
material
these would be
scientists
metal.
invent different materials.
Like metal
for the
on
building.
it. The zip was up popping.
Is that what it is? All right. So, what did you think of your investigation?
It was mysterious kind of. Yeah.
Exactly. I saw people discovering things and wondering what they were, and wondering what they were missing, and wondering what it all meant. And that's what we're going to work on together to figure out. Are you ready to do another investigation this week?
Yes.
All right. We're going to have 5 different kinds of materials at different stations. And we're going to try to find out about them.
Need some water.
Kind of smooth too.
Oh, it's smooth and that's
Yeah. All
All right, now squirt it out just so you can see. Oh, okay. So, but those first few drops were the way you want to do it when you get over to here. Okay? Ready to try?
That's the same as this.
that's okay. It's still okay to try, right? You won't discover anything unless you try.
What will happen to this now? Oh, you can see up really closely with the water. 1 drop. Okay, good.
Come down to eye level. What does it look like?
It's like staying and it's bubbly. It's not absorbing.
What are you doing with this with this material?
When it's wet, it's a lot easier because it makes it more squishy.
Hey,
But if it was like
It's soft. It feels soft. Okay.
That was a great one. Did you hear Griffin? What did he say about the droplet?
Like the droplet just spread. So which number?
Now, that's kind of flat. Look at how I'm doing it. I'm right here.
And then when they put it
Oh my goodness. You think it's tiring doing science?
No.
Seems so exciting.
Yeah. It seems so fun. It's so I'm not tired.
So station 1 was rock, station 2 was wood, station 3 was clay, station 4 was foam, and station 5 was wax, right? Today, we have cubes of everything that we tried to make exactly the same size. So do you think that if you compared a cube of wood and a cube of wax, that would give you the answer about which is heavier? Yeah, okay. So the blue part is lining up with the little line below. Okay, so that means it's perfect and it's ready to try to weigh something. All right, you've got your data table. Are you doing measuring now?
Do you guys have a
That's
plan?
great.
Are you working
Yeah,
together?
Okay.
Tyler, are you working with Reese? Should have been up here.
Let's see what else goes.
Okay, and remember we're doing grams, so you want to put G or grams there. Put marble down here because that's the first one. Or rock with a circle, I think. Because we don't actually know it's marble. We think it looks like it. But are you absolutely 100% sure it is? Perfect. Okay.
Let me feel this one. This one's kind of heavy. This is heavy. But that marble's heavy too.
what are you gonna put on this title here?
Centimeters.
Yeah.
What was that one?
Yep.
I put a lot. Hold on, you got it.
So what do I see you doing here?
Well, we're measuring the wood to see if they're both the same.
So you were interested in comparing it?
That one's just a little bit.
That's 12, so now we're at these two.
Take one pen out and make it one.
Now, what else do you have left?
But this is.
You have this and that. Yeah, so you're going to add 10 to 15.
Do it a science way?
Yeah. Do you have a data table that looks like this? And it has the material here?
Yep.
And it has the weight over here?
Uh-huh.
So we can put dry weight on top of that. And then we could make another column that say the wet weight.
Wet weight. Wet weight.
And then you put, let's say we put wax here, and you have a number already for that. And then you put the wax in the water and take it out and weigh it. And what happens to it when you put it in water? Yes.
It makes it heavier.
That's
Because
what you would.
the water is a type of weight.
Exactly, it is a type of weight. Can you write that in your notebook? That would be perfect. Okay, you can just do another column right there and put wet. Then you're set to go. That's a beautiful, is that your data table that you made? That's fabulous.
This one sinks all the way to the bottom. But we have to do this first. Yeah, because then we can't do it dry. Then we can't know what it's like dry.
He's going to tell you when to take it out because he went really close to watch it.
Alright, take it out. Take it out. Last 30 seconds.
Okay, good. Now, what are you going to do with the excess water?
Ooh, it
Yeah.
doesn't look rough anymore. It's still 25 grams.
Okay, so write that down.
So 25 grams.
Yep, and you'll continue to do that with every material.
So that means this is heavier. So then let's take a 2. It's too close to that one. This one's too heavy.
So see what it weighs.
Let me try.
Oh, yeah, it went up this way. Now what you do is you move this.
You guys want to do a group of 3, so it's less people?
Careful. Now let go. It has this one.
So Ron, can you make a little boat that looks like this and put the wax in it?
Then
I want you guys, another person to take this.
look on the back.
Can I borrow this?
Wait, use this.
All right, so bring your styrofoam and your wax over here. It's very hot. Okay, and then we'll put this on here at the same time. Okay? All right, do not touch it.
I think this one is saying it's 9.8, but that's pretty close. Are we ready to get that melted? Or not?
What we do is let's get it melted. I'll do some.
Here we go.
Miles, do you have my Griffin, let's just leave ours.
All right.
So you can. Okay, Griffin.
Where's our laptop? One right there. All right.
So let's give it a few more minutes until it maybe all of the solid melts, and then we'll take it off, okay? What's the wax doing over there? Squishy? Okay, so it's still
It's
soft.
evaporating. It's evaporating.
I need scientist eyes to observe, right? Okay, so let's take this off. It is hot, so let's
Write in
just
your
watch
journal.
what happens.
Can I take
I
my
want you
journal?
guys
Are you
to
done enough?
observe
Do you
what
know
happens.
So I can dump
Look.
it for them.
Okay, so what is it?
It's a liquid.
It's a liquid.
Well, it's kind of like a candle, like
Okay, what did it start off as?
wax.
Okay, so even though it might be a liquid, is it still wax?
Yeah.
Yeah, because material doesn't change, does it? It's still wax. What's your prediction?
It's gonna be small.
Okay, there you go. You can. It should be cooled off. You can touch it.
Oh my gosh! Whoa!
Oh!
Awesome! Can I hold it out for you?
What did it do?
Keep this overnight.
It's a styrofoam?
That's the big cube.
It's hard now, really hard, not soft.
Yes.
And now it's smaller. You should
Right.
weigh and see if it weighs more. And the little dots got really smaller. And then it did. Stuff in there started to stick together.
Where's the rest of it?
Alicia, our thing is it. This is it.
How did it?
When we put the styrofoam on the heat,
Yeah.
you know how styrofoam has like the air, like where there's spaces, where so there's air in it. And when they put it on the heat, the air starts to come out, and then it starts to shrink smaller, and then it starts to get all like flat and stuff.
I'm Miss Sparrock, I'm with Flying Cloud, and I'm here to do some dance and movement with you that connects to the science you've been doing. I'm going to ask you all to stand up where you are. Okay, and we're going to start a really simple sequence. 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Edges. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and pose. All right, control. Very good, second grader. Who's ready for a challenge? Me. Show us with qualities what your cube is like one of the cubes you studied. So you might want to, with your partner, choose a material and say, oh, we're going to be wax. And then that might give you an inspiration for the kinds of movements you're going to do within your cube that help us show wax. Okay, so what kind of movements do you think might work for a rock?
Well, since there's 3 of us and we might want to do it, we have the and then we'll go.
7, 8.
Edges, 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 faces, 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 edges, 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 edges. I'm melting! I'm melting! I'm melting! I'm wax! I'm wax!
All of our materials were roughly cubes, right? I guess you had some that were other shapes that but let's pretend they were all cubes. That's what they all have in common, right? Their shape doesn't tell us about the material. But these properties that you just helped me with, they help me tell what makes wood different than foam. So our next step is going to be to make movements that represent, we're going to work on wood first. Each thing about wood. Do you want to add something?
Yeah. Like for the lines, you could go like.
So the lines.
Like.
Okay, let's make lines with our hands and with our feet. So this will be for a count of 4. When we're thinking about what wood looks like, we'll make some lines. Okay? Now, can we show the different kind of roughness of foam so that it's not the same way we showed it for wood?
Ooh, look. Or like this.
Does that make it more rough?
Look at how like this.
Your hardness was right through, right? And your floating was like this. Your floating was jumping. And now you guys get to get heated. They're just going to be solid. And shrunk. All right, let's give them a hand. What? A group of creative people with lots of ideas about how to express properties in a totally different way than using words, right? Even when I went to college and I had to write very, very long papers, I would use moving around my room and dancing to help me come up with my words. Really? Yeah, because somehow moving around and going would make me think of different ways of saying something. So for some of us, our creativity, even to translate it back to words, can come through something like movement. So I invite you to try that.
This is not a science studio today, it is an art studio. And do you notice we have a guest?
My name's Robin, and I'm a sculptor, and we're going to be looking at surface texture and the different absorbency of the different materials, and trying to see what we can learn about the different materials by actually painting on them and figuring out what they do.
I want to get stoned.
And in terms of doing painting on it, probably those are better.
I got that purple.
What are you finding out about the absorption?
Oh, look. That. What do you do? This. That's that.
Yeah, do that thing again. Look how it shows up all the circles.
Yeah.
Isn't that
But
cool?
it looks like it's flat. Okay, that's enough.
Show Robin what you were doing, Stella.
Now what's happening with the absorbing here, and can you see the grain of the wood in this? Tell me about this. Why is that not all red?
If I put like water on it before I paint it, I'm wondering what will happen, or if it'll just stay the same.
If it'll be the same or different, that's
Well,
a great
there's
question.
wood absorbing and there's stone absorbing. Just think about it, because I want you to go back to your lab notebooks and see what you know about absorbing now that you've done it on different materials.
Today what we're going to be building is structures that you can use any material you want, like any combination of materials, but they have to withstand wildfire, so that's like really high heat, like flames, rainstorm or flood, so water, earthquake, windstorms, heat waves, and blizzards. So those two are like about temperature and how the materials react to temperature. So we're going to have you guys do a little bit of planning first. Just a quick sketch. It doesn't have to be super thought out. And so you're going to come up with your list and with your drawing, and you're going to show it to us, and so we can say, all right, you guys are good to go, and then take them back to your table and start building.
So we have 2 little pieces. Oh, 2 little. We have 1 little. Perfect. One more. Black to make the blue. Yeah. There we go. Now we are ready for a rainstorm.
Why do you think this is a good?
That's really good.
What do you think's making it work so well?
Because I have lots of big pieces, and then it goes little.
So you got the weight mostly at the bottom there?
I chose very, very
So you're going to change your design? That's a good idea.
done.
Right now we're trying to think about the function of things, not just if it looks pretty.
It's not gonna look pretty. It looks decent.
Because if the wind came through, it would just go through all these holes here, right?
Yeah, but
Like
it
in-
could go off this thing.
Next week, your teacher's going to be able to put a photo of your structure up ahead of you, and you're going to stand next to it and explain it to the other kids, what you were trying to build and withstand, and what materials you use, and they're going to ask you questions about it.
Yeah, Minecraft.
It's a beautiful
So
architecture.
it looks kind of actually looks like there was a fire once, and like that kind of thing.
Yeah, it looks kind of burned up there.
Yeah, and like if there's like a blizzard, heat wave, windstorm, earthquake, rainstorm, or flood, or wildfire.
Yeah, so
Or it could try.
I guess you're still thinking about materials. Yay!
Or it could try to survive every disaster. What I learned from science, that like all the materials, they're just so different. They all have their own properties, and that it really amazes me of what can happen. It's really truly amazing.